So I mentioned this connection between an NFC phone, the chip, with a smart door. So I don't know how many people are familiar with NFC or if they haven't messed with it before. NFC has different applications, access control, mobile payments. I don't know if you have seen any like commercials on TV where you can kind of put your phone in there and you make a payment and it gets completely wired from your bank and you proceed the transaction in 1 second instantly. You just tap it and it's done. So there's some other things like loyalty programs, store marketing. Like if you're trying to purchase a thing, an item, you can just pretty much search it and automatically do it instantly. Location-based services, you can save in your phone. Actually, there are some chips that they make for the NFC. So what the chip does, you pretty much program it. There's some applications like Samsung. They create an application for the user so they cannot have to do any coding on it. They can just input, like for instance, a URL, and you save the URL to that chip. You put your phone on that, and it will directly take you to that. So it's something like you save it, you tap your phone with it, you get it between a range between I think 10 centimeters, which is around 4 inches. That's the range between the two devices. So can you switch the slide, please? Like we said, you want to look this. So we're going to be focusing. I'm sorry, we're going to be focusing on access control. That's what our project is. Go ahead. So NFC. It's a communication between two devices, right? So we are using two devices. We're using our phone, which is a smartphone, right? It has to be a smartphone. It has to have, right now, Apple does not have compatibility with NFC. So Android is the one that is operating that. So we have our phone, and it's connecting, it's doing an interface, and it's exchanging data between the actual device and the NFC chip that we have located inside the door. I don't know if some of you have seen any, sometimes they have cards, and some corporations where they have a card and they sort of slide it. Well, our phone is being sort of representing that particular card, right? So the thing that we have presented is we have our chip. We have our phone is a smartphone, and it's communicating with the chip like peer-to-peer data. So it's sending communication through the data. So you turn on your NFC. Your NFC has an ID, right? You register your phone, and it has an ID. The chip reads it. In our case, it was the Adafruit. Can you go back, please, John? Okay. I'm sorry. So Adafruit is just a brand. It's just an NFC chip, and it tells you here that it operates at 13.56 megahertz. So this is a part of our radio frequency. So it is a communication between radio signals, right? So NFC will be recognizing the signal that you input from your phone towards the chip, and what the chip is going to do is going to say, okay, well, this person has the right ID, this person has the right connection, so I'm allowed to keep on going with my code. This person has access to this door, this application, whatever you want to call it, this marketing. So what that is doing is I input my code into it, and that gives me access. Now, you do have to have it, you do have to be between a certain range from it. The range, like I mentioned, is 4 inches. Sometimes it can be less, sometimes it can be tapping. You have to sometimes tap it, something that is, I guess, between the application of the phone, the update that you have on your phone. Some phones can be updated, and the most recent ones, you pretty much work between 2 inches. They work very well. So the communication between, like I mentioned, is 13.56, and like I said, it's between two devices. So it's transferring data between the devices. You are inputting the data, and the data is being read. So it's a read and write type of communication. And the application that we have used is the Adafruit for our project. So once the communication has been sent from your phone and the chip has been recognized this information, it's going to send a signal to our microboard. So Arduino is the one that we chose, and the chip is telling Arduino, okay, you can keep going with the sequence, with the code, you can have access. And we have John to talk to. Okay.
We're using an Arduino board built around an Atmel AVR hybrid controller. We're using, as it happens, all digital outputs. Well, only digital outputs, not all of them. We're using a serial link to the NFC chip, the 532. We're using a total of 3 pins to control. Oh, I am. I can tell if I was quiet. But yes, we're using 3 pins to drive our DC motor. And we're using the 5 volts off the Arduino board to power the, 3 volts. We're using the Arduino board's power systems to power the low voltage side of our dual H bridge. Our dual H bridge is the L293D, which is used to drive a DC motor forwards and backwards, which is directly linked to our lock. The Arduino is linked with the NFC chip, with a reed switch for checking if the door is closed, and the L293D, and they're all powered by they all derive their power ultimately from a 9-volt DC wall plug. Now, in terms of programming and monitoring, the Arduino uses a polling loop to check for an NFC signal, evaluate and check against its list of allowed codes, and either announce that it will lock or that it doesn't recognize the code, and proceed to unlock the door and wait for the door to be closed after a certain delay in order to relock.
Alright, so next is the Android app. Like Adrian said before, the reason we use Android is because they actually allow you to mess with their stuff, unlike iPhone. iPhone doesn't allow you to get in there. So the Android application that we used was, first of all, there's 3 types of uses we could use. We could either read, write, or we could use something that came out a couple years ago called postcard emulation. And that came out in Android 4.4, I think, or Android 9 now or something. And that allows you to emulate pretty much any card that's an NFC card. And that's pretty much what we use. And the way that works is the chip that we use sends a message our way, and if our phone recognizes that message, then it will send back an encrypted message, and then that's when the Arduino will determine if that message, encrypted message, is the right code. It will decrypt it, and then it will determine if it's the right code. So our service app, so this is actually what it kind of looks like. It's pretty much just a service app. You don't have to do anything. You just turn on NFC, and it waits for that signal to come in. It has to be the right signal to come in for it to send it back. And like I said, the application only works on Android 4.4 and above. The next thing we're going to talk about is the lock mechanism. The lock mechanism was a little difficult to maneuver. One of the things we wanted to do is still allow key access because we didn't know there was ever going to be a power outage, or if we use batteries, the battery's going to die. We didn't want to just leave either the phone in a locked state or an unlocked state, and you can't really mess with it. So we still allowed key access, and so that was a little difficult to maneuver because we didn't want, if you look at this gear, we didn't want the gear to start moving the motor, which was hard to do anyway. So what we ended up doing was we ended up using the clutch gear, which allows movement here without moving the motor. And it has 2 little pins inside that will lock into each other. So when the motor does move, it will move a certain amount and then lock into it, and will eventually turn everything in there. So it allows both the key to be used and and the motor to do it on its own.
So when it
comes to the L293D, it's a monolithic device connected directly to the Arduino and to the DC motor. The reason why we chose this chip is because it has a reversal polarity of how you can see going to lock or to unlock it. So it runs at 5 volts and it delivers 9 volts to the DC motor. You can actually connect 2 DC motors at the same time because it has 16 pins. In our case, we were just using 8 pins. So when input 1 is high, the enable is set through the code to always be high. We have the output high. When input 2 is low, enable high, and the output is low. So the door will lock in the same manner. When input 1 is low and the enable is high, it will go low, and then input 2 is high. With the enable high, it will go to unlock the door. And like I said, the chips run with 5 volts and it delivers a 9 volt to the DC motor.
Can you go back, John? I want to show them what that actually does. So what he's explaining is that that motor is going to rotate one way, right? And so you have a latch on the other side of the door. So the latch will actually rotate 90 degrees. So what happens if you only have it going one way, right? It's going to try to go another 90 degrees, which will be 180 degree rotation. But we don't want it to go that way. We want it to go negative 90 degrees. So that's where that chip comes into place. That way the lock can come, the latch can come the opposite way, like if it was actually a human hand moving it. But it will rotate one way to lock and it will rotate the opposite way to unlock. And it's necessary to have that particular chip in order to make the gear go like that.
Yeah, in terms of cost, we had a budget of $800, and we were able to minimize it to $170. That doesn't include the door and everything else. Is just the motor by itself, which is mainly all the chips, the DC motor, and a couple wire connection.
So this is a very competitive price. We had been going to Lowe's and Home Depot, and we actually were comparing prices between some Bluetooth devices, right? So there were some Bluetooth locks actually that already come with an app and whatnot. So the cheap ones were from 120, 150. Some of the more sophisticated ones, you want an application and whatnot. So this can go up to $200. So I know the prices get in there into those categories, but we have to take in consideration they are commercialized. So they're selling their items in a more. They have a market for this, right? So if we were to mass produce these items, we will be getting everything a little bit more cheaper. And also, we actually created all the casing for our connection. So we have a 3D printer, and we were actually doing some 3D modeling, creating the perfect fitting for the gears. Unfortunately, when we were coming on our way, one of our pins broke, and it actually stopped our gears for actually rotating. So we were not able to demonstrate the actual functionality of our project. But the fact that we can actually do some of this stuff can say that this can be implemented in someone's house. It doesn't necessarily have to be a different latch, or you go buy one of these items at Lowe's and you have to remove the one that you have right now, and you actually have to go install it or download an application. This item that we have created can just go on top of your normal key. It's called keyed solenoid lock. So this can just go, it's a normal, you put a key in and our device will be able to make the rotation locking and unlocking due to the fact that we can actually modify and connect the casing and modify it according to the aspects of your door and the lock that you have existing right now. So some of the improvements that we have come up with is that actually we try to be competitive with the prices that we've seen out there for some of the smart locks that are down there. But we can actually go and expand it more. We can actually create a more sophisticated app that will tell you something like our real-time system that will tell the user how many times the house has been accessed, right? So you have, let's say you marry, right, your wife and your kids, and everybody has a smartphone and they have their personal ID. So this application will be able to save their phone and create an ID particular for that person. So you want to check at what time your son got from you know, like you let him out at that night and you wanted to say, he said, okay, I'm coming back at 10. You can actually see that he came after midnight. So one of those things, the implementations is that you can actually check how many times your house been accessed and whatnot. So the improvements for this and the purpose of our creation is more for like it's a way to help someone access their home, right? So I've been in situations where I'm carrying too many bags, grocery bags, or I'm carrying my nephew, something like that, and I have too many keys and I'm trying to find them and I have like 5 keys in my keychain. And it's just hard for me to do it. So one of these things, we're always on the phone, we're always talking on the phone, we texting and whatnot. So one of these things is you just put your phone in there, you have access to your home. And the good thing about this is that it's very difficult for someone to actually hack it or someone to break into your home in that way by hacking, because this needs to be really close. You actually have to have the device right in front of the chip that we have installed. So one of those features is one of the changes that we can make. And that's it. Any questions?
I have a question. I have a couple questions actually. So for the Android app, y'all created that in-house?
Yes.
Was that done with Android Studio? So you programmed it with Java or
Java, yes.
whatever?
Yep.
So for the end user, if you was to mass produce it and sell it, how would they get access to the app? Would it be available on like Google Play?
Yeah,
Google
we'll eventually. I mean, you can't put it on Google Play and everything.
Okay.
Yeah. The whole point to the app was to make it minimal, especially since none of us know how to really. So we had to learn how to code Java, and it really like you know, like also I was thinking of also like old people don't know how to go into all that. So you don't really need to do anything except just turn on the NFC and wait for the code to be sent, and if it's the right one, we'll send it back.
So if the end user was to, like, for example, misplace their phone or lose their phone and they're not at home, what type of safeguarding features do you have in place? Like somebody found it and knew where they stay and went up and tried to get in. Is there any way, I guess, locally that they can disable?
Well, as of right now, I guess you have the whole. We didn't put anything on our end for that. There is you could make a PIN you put in, but on our end we didn't do much about that.
Any other questions? Yeah. So you said that it sends an encrypted signal between the phone to your device. Like, I guess like what handles like encrypting and decrypting that, and like also how much information is in that signal that it's transmitting between?
It's
A handful of bytes.
yeah.
Small amount of bytes.
It's just a code, unlock code.
It's a simple AES encryption and decryption for that.
Yeah, so why did you choose a polling mechanism as opposed to an interrupt-based design?
Well, we went.
We thought about doing the interrupt because we also came up with another difficulty that can come into play. So right, you go outside and you're taking your trash and you're gonna go outside, right? And we have a delay right now. Is it 5-second one? Yeah. So it's a 5-second delay. So we have a sensor right next to the door. So when the sensor reads that the door is closed, it would automatically lock in 5 seconds. We thought about putting an interrupt so we can press a button and it will stop any type of mechanism. That way you have access, or you have more people coming in and you don't want to be closing the door and having to input your code every single time they come. Those are one of the improvements that we actually thought about doing, but we did not mess so much with that due to the fact that we wanted to keep the codes a little bit more compatible with some of the items out there. But those are some of the improvements that can happen, because you can forget your phone inside and your keys are actually inside, and you can end up actually locking yourself outside your home, and no one wants that, right? So another of the, I guess the things that are good about our design is that sometimes you forget your keys somewhere, right? So you call locksmith and that's already $150. it can be sometimes costly when you try to access that. So if you have your phone with you and you forget your key somewhere, you can always have that. You always have that access. And if you have more people living with you, you can actually have them bring them to you and whatnot. Not the actual physical key, but a device that could access your home in that aspect.
Any other questions? One quick question. So the key remains in the lock, inside.
The
And you are
physical
making a
key?
movement, huh?
The physical key?
The
or
physical key.
No, the physical key can be outside. You have the key with you, right? So that what we have there.
Yeah.
Let me see if I can rotate this. So this is the actual latch, right? It's just a key locking mechanism. On this side, you can input actually your key in here, and it will make the gears. I think if you remember, we had the gears, and you had access to actually move it, right, without having to mess with your gear motor or fighting the gear motor.
Were you asking if there's a tumbler cylinder in the back?
In the back.
So,
how it
No,
works.
it's just a simple shaft
So
in the back.
in the back, we didn't actually have this, but we had created it, and here is our NFC. This is the placement for the NFC actually, and of course here is an encasing for our Arduino and our chip. So the chip is actually being read from the opposite side, but the chip is actually inside, or sometimes it can be installed outside. We didn't want to do any drilling to the door to that fact, but since the communication between can be from 4 inches, it's actually pretty readable if you're in the outside part of it. So this part is going to include that, where the gears go. They go in here, and we actually created this. Juan, can you show them some of the casing that we have created?
So the gears are in
The
that
gears
right
are
there?
inside, right? So the gears are easily to take, and they're just, you just screw it, you unscrew the lid. So some of this, so this is the mechanism, right, what we showed you out there. This is just a part that we had, but we had actually created multiple of these. So here's where the motor has been sitting and all that. So this actually goes in here, and the motor, the cylinder goes in here, and it's connected like that. So it makes entire latch actually go 90 degrees, or I think it's about 45-degree rotation. So this will go here, and then the rest of the stuff is just the connection, the breadboard, and some of the other items that we have used. But it's sort of simple, but I think it's something that someone can benefit from by not having to actually look for the keys, or if they're locked outside, they can just access their phone and enter the home.
It's all machinery and electronics.
Right. So they will be inside. So no one can actually go into your house and try to remove the
Interiors.
the bolts, right? Everything will be operated inside. And if we were to actually commercialize this, you can do all the improvements from inside. And
At
the
most-
user.
At most, we'd have an NFC antenna on the outside.
And since there's no anything,
Public.
there's no cutting to the door. Actually, everything is done through the hole of your actual key mechanism. You don't have to modify it or mess with the person that is buying that item. So unfortunately, we didn't have that to demonstrate today, but we have created it, and just that thing broke, and it was actually not able to spin our gears, so it was not locking. It was sending a signal, and the motor was rotating, but nothing. The gears were not turning, unfortunately. So we didn't have access to actually demonstrate the locking mechanism.
Any other questions? Thank you.
Thank you.